Hey guys, today we are going to be looking at 6-16. And in this problem, it tells us to consider the equation 5x plus 8y plus 10z equals 40. So the first thing we want to do is figure out what the shape of this graph would be. So if we just had 5x plus 8y equals 40, that would be just a straight line, right? Because my x doesn't have a squared, it doesn't have a cubed, it doesn't have a square root, it's just a plain x. So that tells me that I'm going to have a straight line. Now, if we're adding that z dimension, this is going to create what we call a plane, and I'm going to show you what that looks like. So if I use this E tool here, I can put a 5 for my x, an 8 for my y, 10 in front of my z, and then I can make this 40. So if you look at my graph here, this is the graph of 5x plus 8y plus 10z equals 40. And I can kind of shift this around so you can see that it's a plane, right? It's got that third dimension versus just being a straight line. And you're going to be working with this E tool today as well, but we are going to talk about a way to check to see if these are solutions algebraically first, and then we'll jump into our 3D plotter. To check to see if a ordered pair is a solution algebraically, we replace our x, y, and z variables with their values. So I did that here. 4 was my x, 5 was my y, -2 was my z. Now I'm going to solve this out and see if it makes my equation true. So 5 times 4 is 20, plus 40 minus 20 equals 40. So I know 20 plus 40 is 60, minus 20 gives me 40. So this is true, meaning that this ordered pair is a solution to the equation 5x plus 8y plus 10z equals 40. I'm going to show you what this looks like on the coordinate grid as well, because you will be doing both. So on the next slide, you're going to have to use this algebraic process to determine if 3 points are solutions. And then after that, you're going to be using that 3D E tool that I showed you just a little bit ago to check to see if there are solutions as well. Here, I did that by using the plus equation button, and then I changed my values to get that correctly on there. To add a point, we can click this point button, and if we click here, it gives us the option to change our x, y, and z. So I had 4, 5, and -2 as my ordered pair. I'm going to change this color so it's a little bit more easy for us to see. Okay, and then I have this point right over here. So I need to determine if this is a solution or not. And I do that by looking here. I can see that my plane goes through that point. It's a little harder to see this way, but if I rotate my 3D grid, I can see that that is a solution because it fits on my plane.